Hello everyone, let me introduce myself. My name is Alfian Firman Hidayat. I'm from Civil Engineering Department, Diponegoro University. I will present Building Information Modeling or BIM, with the topic is BIM for owners and facility managers. Table of content of BIM for owner facility manager. One is introduction, where owners will tell about BIM. Two is BIM application area for owner. Three is BIM toolkit for owners. Four is an owner and facility manager building model. Five is leading the BIM implementation on projects. Six is barrier to implementing BIM, risk and common myths. Seven is guidelines and issues for owner to consider when adopting BIM. Conclusion: BIM for owner and facility managers. Introduction: Lean processes and digital modeling have revolutionized the manufacturing and aerospace industries. Early adopter of this production process and tools, such as Toyota and Boeing, have achieved manufacturing efficiencies and commercial successes. Lorenzo 2005, an adapter were forced to catch up in order to compete, and although they may not have encountered the technical hurdles experienced by early adapters, they still face significant change to their works processes. BIM adoption history. The AEC industry is facing a similar revolution requiring both process change in a paradigm shift from 2D-based documentation and stage delivery processes to a digital prototype and collaborative workflow. The foundation of BIM is one or more coordinate and information-rich building model with capabilities for virtual prototyping, analysis, and virtual construction of a project. Why BIM? This tool broadly enhances today's CAD capabilities with improved applicative link design information with business processes such as estimation, sales forecast, and operation. This tool supports a collaborative rather than fragmented approach to project procurement. This collaboration builds trust and common goal that serve the owner rather than competitive relationship where its team members strive to maximize their individual goal. In contrast, withdrawing these processes, analysis must be done independently of the building design information, often requiring duplicate tedious and error data entry. The result is loss of value in information asset across spaces, many more opportunities for error and omission, and increased effort to produce accurate project information. Why-beam consensually sub-analysis can be out of sync with design information and lead the error. With beam-based process, the owner can potentially realize a greater return on his investment as a result of the improvement in the design process, which increases the value of project information in its spaces and allow greater efficiency for the project team. Simultaneously, owner can reap dividend in project quality, cost, and future operation of the facility. This is the project life cycle of BIM. There is a feasibility, there is a design, construction, facility startup, operation, facility retrofit. The vertical is value of facility documentation. The horizontal is 1 up to 5 years, design and construction. 20 plus year, there is operation. There is a facility life cycle, such as loss of value due to inoperation of automation, collaboration with this delivery process, traditional design with full paper-based and process, traditional facility management database process, setup of facility management database, integration of FM with big office system, use of as-built drawing for retrofit. The last is update of facility management database. Owner can use BIM to manage project risk, improve project quality, and deliver value to their business. Facility manager can use BIM to better manage their facility. They make strategic decisions in the facility delivery process through the selection of service providers and the type of delivery process they use. This control the scope and effectiveness of BIM on a project. BIM application area for owner. Many owners view construction as a relatively small capital expenditure compared to the life cycle costs or other operational costs that occur over time. This is a table of summary of BIM application area and potential benefit to all owner operator, and owner developer, and a cross-reference to case study. There is a specific BIM application area for owner, space planning and program compliance, energy analysis, design configuration, scenario planning, building system analysis simulation, design communication review, quantitative and cost estimation, design coordination, cost prediction, scheduling simulation, atau R4D, project control verification, pro forma analysis, operation simulation, commissioning and asset management. Next one is benefit to all owner, ensure project requirements are met, improve sustainability and energy efficiencies, design quality communication, building performance and quality, communication more reliable and early estimated during the design process, reduce file error and reduce construction costs, communicate schedule visually, track project activities, reduce on-site labor and improve design quality, improve cost reliability, building in performance and maintainability, velocity and asset. The next is design assessment. Owner must be able to manage and evaluate the scope of the design against their own requirement of every phase of a project. During conceptual design, this often involves spatial analysis. Additionally, an ever-increasing proportion of projects involve either the retrofit of existing facilities or building in urban setting. The next is integrated development of programmatic requirement. During the programmatic and feasibility process, owner working with their consultant, they develop programs and requirements for a project. The next is they often perform this process with little feedback with respect to feasibility and cost of various programmatic feature or project's requirement. One potential tool activity is Brimstone. Improve program compliance through BIM spatial analysis. The case study include figure-based demonstration how a building model can communicate in real time, especially in data form to check compliance with requirement, different color, or automatically assigns to room based on their dimension and function. Receive more valuable input from project stakeholders through visual simulation. Owner often need adequate feedback from project stakeholders who either have little time or struggle with understanding the information provided about the project. Rapidly reconfigure and export design scenario. Real-time configuration, however, is possible either in the model generation tool or a specialist configuration tool. This is an example of figure rapidly configure and export design scenario. There is a 3D model in above, and there is a program report after grouping. There is a program report by element and etc. The next one is simulate facility operation. Owner may need additional type of simulation to assess the design quality beyond walkthrough or visual simulation. This may include crowd behavior or emergency evacuation scheme. Complexity of building infrastructure and building environment. Modern buildings or facility are complex in terms of the physical infrastructure and the organizational, financial, and legal structure used to deliver them. Complicated building code statutory issues and liability issues are not common in our building market and are often a bottleneck of a significant hardness to a project's team. Due to and processes can support owner effort to coordinate the increasingly complex building infrastructure and regulatory process by coordinating infrastructure through fully interactive 3D models of mechanical, electrical, plumbing, architectural, and structural systems. The next one is producing higher quality and maintainable infrastructure through interactive review of coordinate model, preventing litigation through collaborative creation and sync of building information model. The next one is sustainability. The green building trend is leading many owners to consider the energy and efficiency of their facility and overall environmental impact of their project. Sustainability building is good business practice and can lead to greater marketability of the facility. Building model provides several advantages over traditional 2D models due to the richness of object information needed to perform energy or other environmental analysis. There is consumption of energy through energy analysis and improved operational productivity with model creation and simulation too. The next is cost reliability and management. Owners are often faced with cost overrun or unexpected costs that force them to either fail engineer, go over budget, or cancel the project. Survey of owner indicate that up to third of construction client report cost overruns. The reliability of cost estimate is impacted by a number of factors, including market conditions that change over time, with time between estimate and execution, recent change, and quality issues. This is cost reliability and management. The upper limit is the 50%. The lower limit is 30%, and the BIM can make reliability on contingency up to 15%. This is a preliminary state. The budget can make lower than preliminary estimate. In the figure of right is the project life cycle. There is the ability to influence cost. There is a construction cost. 0% starts to finish 100%. There's a conceptual planning of our facility studies can make ability to invest costs higher than design, engineering, procurement and production, and operation and maintenance. The next one is BIM application area for owner, time to market scheduling management. The one is reduce time to market through the use of parametric model, reduce schedule duration with 3D coordination and verification, reduce scheduling That is with BIM-based planning. Quickly respond to unforeseen file coordination with body BIM model. So the BIM application to market scheduling is reduce time to market, use a parenting model, use a 3D coordination verification, use a BIM-based planning, and use coordination with body coordination BIM model. This is an example of figure of schedule management. There is a figure A is department view. There is a top view for department view. There is a B is floor view from department. The C is all floor or for design of department. There is a D is activity type legend. Figure E is activities in progress, and F is facility model hierarchy. There is a facility and information asset management. There is a commission of building more efficiently. BIM can make a building commission is more highly. The next one is quickly populate to a facility management database. So BIM can make a quickly populate to manage higher or big facility management. The next one is managing facility asset within asset management tool. The last is rapidly evaluate the impact of retrofit or maintenance work on the facility. This is a figure example of facility and information management. There is a 3D model and there is information in the left. There is a detail on the left. Next is BIM tool for owner. There is a BIM estimating tool. BIM can make estimate the building with the 3D model of building. The next one is facility and asset management tool. BIM can make a facility asset management tool in before explanation in. So BIM can make facility and asset management. The next one is BIM can make operation simulation tool. So the 3D of model can make of simulation operation. There is a class detection or etc. So this is a BIM estimating tool. Owner use estimator to baseline their project cost and perform financial forecasting or pro forma analysis. Often these estimates are created early in design before the team develops a fully detailed building model. Estimates are created using square foot or unit cost method. This is estimated cost in BIM use area unit by owner representative or estimated consultant. The next one is facility and asset management tool. There is a most existing facility management tool either rely on polygonal 3D information to represent space or numerical data entered in a spreadsheet. So the BIM can make polygonal 2D information and data entered in spreadsheet. From most facility manager perspective, managing space and their related equipment and facility asset doesn't require 3D information. But 3D component-based model can add value to a facility management function. This is an example figure of facility and asset management tool. There is a 3D model and there is a 3D information in the left, and there is a space common, big area, cafeteria common, there is ATM, there is a circulation, there is a fitness, there is a washroom, lobby, security, service, smoking area, and etc. The next one is operation simulation tool. Operation simulation tool are another emerging category of software tool. For owner that use data from a building information model. More typical example of operation simulation tool do not involve specialist simulation, but the use of real-time visualization or rendering tool that take the building information model as input. An owner and facility manager building model. One is owner need not only be concerned in the kind of BIM tool available, but also understand the scope and level of detail they desire for a building model of the project. Provides a framework for owner to understand the relationship between the level data and the model mesh, space, and construction level data. See vertical direction and the scope of the model, including spatial and domain-specific elements that are architectural and detail mechanical, electrical, plumbing elements. This is a conceptual diagram that specific various BIM during facility delivery. There is in a practical direction, there is a from conception to realization. In the lab, design, construction, BIM application, there is a pro forma analysis, scenario exploration, program compliance, building performance, operation simulation, emergency, order compliance, estimation, coordination, schedule, verification. In vertical direction in direct, there is a post-construction, asset management or BIM application. There is configuration pre-sale, as-built, commissioning, project management, financial asset management, operation simulation energy, emergency, performance monitoring, and configuration retrofit. In horizontal direction, there is a level of scope by component type and application. There is a component project. There is a concept design. There is a massive space in the design document. General components. There is a site, space, architectural, structural, MAP, then contractual level detail component. There is a manufacturer, dedicated component, custom on-site, and the as-built with operational data stats. There is a custom asset object sensor link component. This is a table of owner building information model. There is a purpose to support program completion facility, to support commissioning activities as performance specification, for construction analysis, to budget and schedule maintenance, for replacement cost and time period, to plan and prepare for evacuation, to monitor and track progress of vision, to monitor building sensor, and real-time control of building system. During the BIM implementation on a project, develop guidelines for BIM on project, will internal leadership and knowledge, service provider selection, will and educate and qualified network of BIM service provider, some deliverable requirement, modified contracts, and contract language. This is a relationship between the BIM application area and the requirement, scope, and level of detail in the building model. Level of detail, there is a concept, generic construction. There is a BIM application area, there is a vision construction, and post-construction operation. In a concept, there is a massive space site, generic, architecture, structure, MEP utilized. Construction level, there is a prefabricated component, custom component. In the component property type, there is a geometric properties, material properties, functional, cost, and etc. This is a facility delivery process and life cycle. In the left, there is a traditional deliverable to owner, and on the right, there is a deliverable with BIM technology and process. In the traditional deliverable to owner, there is a project scope, there is a conceptual plan, there is a contractual drawing and specification, there is a as-built drawing. In the deliverable with BIM technology and process, there is a process project scope. There is a conceptual BIM model, estimate plan, BIM model, and as-built drawing. And the center of facility delivery process, there is a market demand needs, facility concept development, design and engineering, construction, UP startup, and operate maintain. The next one is barrier to implementing BIM risk and common myth. Process period. The one is the market is not ready. Adopting among architect, engineer, contractor is moved well beyond the early architecture stage. The project is already financed and design complete. Training costs and learning are too high. It's very expensive. Everyone must be on board to make the team effort worthwhile. Too many legal barriers exist, and they are too costly to overcome. Issues of model ownership and management will be too demanding and on owner resources. Technology risk and barrier. Technology is ready for single discipline design, but not integrated design. So they are not yet defined or widely adopted. So we should wait. So this is a question and issues for owner to consider when adopting BIM. There is a perform a pilot project with a short time frame, small qualified team, and a clear goals. Do a prototype dry run, focus on a clear business goals, establish method to assess progress. The last one is participated in the BIM. Conclusion is owner can realize significant benefit on project by using BIM process and to streamline the delivery or higher quality and better performability. BIM facilitates collaboration between project participants, reducing error and field change and leading to more efficient and reliable delivery process with reduce project time and cost. There are many potential areas for BIM contribution. Owner can use a building process model to increase building performance, reduce the financial risk, shorten project schedule, obtain reliable and accurate cost estimate, assure program compliance, optimize facility management and maintenance. Thanks. Thank you for the attention.